Given that the number 1.01 can be written as 1 plus 0.01, use the binomial theorem to find the value of 1.01 raised to the power of 10 to 3 decimal places. Alright. So, remember what we have here is the binomial theorem, so you should remember what the binomial theorem actually says. Now let's remind ourselves of it. Suppose you have, say, x plus y, say to the power of 3. Alright? What this is x plus y multiplied by x plus y multiplied by x plus y. Now let's multiply out these first two x plus y's. This is x times x, which gives you x squared, plus x times y, which gives you xy, plus y times x, same thing as xy. Right, that would be yx, but it's the same thing as xy, plus y times y, which is y squared, and that is multiplied by x plus y. So this is x squared plus x plus y plus x plus y. These two add up to give you 2xy plus y squared and multiply by x plus y. Now this is x squared times x, which is x cubed, plus x squared times y, which is x squared y, plus then you have 2xy times x, that will give you 2x squared y, plus 2xy times y, that will give you 2x y squared, plus then you have y squared times x, that will give you x y squared, plus then y squared times y will give you y cubed, equal. Adding up these things together, you have x cubed at one end, x squared y plus 2x squared y gives you 3x squared y, plus 2xy squared plus xy squared gives you 3xy squared plus y cubed. Now, remember you have a certain pattern here. So this is x plus y cubed. Now notice, if you put in all the powers, this is y to the, this is x to the 3, then x to the 2, then x to the 1, and then here, let's give it a little space here. What you would have is x to the 0 y cubed. So the power of x goes, which is on the left, goes from 3, then 2, then 1, then 0. So this is suggesting that if you have x plus y to the n, you have x to the n, then x to the n minus 1, and x to the n minus 2, same as 3. 3 minus 1 is 2, 3 minus 2 is 1, and so on and so forth. And you go right down to x to the n minus n plus x. Well, x to the n minus n is 0, so that would be the last x. Now what happened to the y? The powers of y. This would be y to the 0, y to the 1, y to the 2, y to the 3. So the powers of y, the term on the right, start from 0 and goes up. So it's y to the 0, y to the n, y to the, oh, not y to the n, y to the 0, y to the 1, y to the 2, and so on, well, up to y to the n. So those are the x's and y's. What about the coefficients, the numbers that multiply x and y? Well, you have 3 numbers in each case, or 3 letters in each case to arrange. You have, in this case up here, 3 letters to arrange. You have 3 at first, so it's C. Well, let's not put it this way. You have 1, then 3, then 3, then 1. Okay, good. So, the coefficients in this case, 1 would be 3 x's if you consider that you're arranging x's. This would be 3c3. If you calculate 3c3, that's 3 factorial over 3 minus 3 factorial, 3 factorial, which will be 3 factorial over 0 factorial, which is 1, times 3 factorial, that's 1. So you get the 1. How about this 3? It would be 3c2. 3c2 is 3 factorial over 3 minus 2 factorial 2 factorial. 3 factorial is 3 times 2 times 1 over 3 minus 2 is 1. 1 factorial is 1 times 2 factorial is 2 times 1. So 2 times 1 cancel 2 times 1. So that gives you the 3 here. Now, this would be 3c1, which will be the same as 3c2 when you calculate it. And then this is 3c0. You have 0 x's arranging, so 3c0 is 3 factorial over 3 minus 0 factorial 0 factorial, which is 3 by 2 by 1 over 3 minus 0 is 3, is 3 by 2 by 1 is 3 factorial times 0 factorial, which is 1. But all of this cancel itself, so gives you 1. Remember, what we're doing here is just reminding ourselves how to get the binomial theorem. So the coefficient here would be what? In this case, it would be NC plus NC something. Notice the 3 is consistent at the top here. So in this case, NC, NC, but NC what? If you imagine that you're arranging X number of items from N available, X would be, this would be N, NC, N minus 1, NC, N minus 2, and so on. So it's NCN. Alright, so that out of the way. Let us consider what's going on with the question. Now that we have the binomial theorem, we've reminded ourselves what the binomial theorem says. Let's see something here. What is 1.01 to the power of 10 to 3 decimal places? Let's work it out. 1.01 to the 10 is same as 1 plus 0.01 to the 10. See that? Now, using the binomial theorem, is the same as, now, let's look at the numbers first and the powers. It's 1 to the 10th, just like how we had x to the, and it starts at the top and goes down to 0. It's 1 to the 10 plus 1 to the 9th plus, then you have 1 to the 8th plus 1 to the 7th plus 1 to the 6th, and so on. You won't need all 10 of them, you know, because the question says to 3 decimal places. And if you write out all 10 of them, it means you're going to a lot more than 3 decimal places, but you only need 3. Now, 0.01. You multiply this by times 0.01 to the, now notice, the y, the power starts at 0 and goes up. So, it's 0.01 to the 0, then this time 0.01 to the 1. You know, I should write it out with more space between them, you know. Alright, this is the 1 to the 10 times 0.01 to the 0. Now, the coefficient is going to be 10C10. I always think of arranging the number of items on the left. Alright? 10 in this case is starting with 10C10. I don't think it's easy to see this color that well. I'm writing this color 10C10. Alright, plus the coefficient next is going to be 10C9 because there are 9 ones, and then we have 1 to the 9 times 0.01 to the 1. Notice the powers of the 1 and the 0.01 always add up to 10. Alright? So what we have here is 1 to the 9, 0.01 to the 1, plus the coefficient here is 10C8, because we're going to have 1 to the 8, 0.01 to the 2. Alright? Remember, the 1 has power of 10 and going down one at a time. 10, 9, 8, 7, and so on. Power of the 0.01 starts from 0 going up, so it's 0, then 1, then 2, then 3, and so on. Here we have 10C7 and 1 to the 7, 0.01 to the 3 plus. And we're going to have 10C6, 10C6, 1 to the 6, 0.01 to the 4 plus, and so on and so forth, and on it goes. Let's work these out now. Let me see if my calculator has a combination on it. No, no. My calculator doesn't have a combination on it. What I'm going to do is work it out offline using my calculator. Alright? And ensure you follow with yours. In fact, you should just like with other questions, make an attempt at working it out before you watch me work out my solution, alright? So 10 NCR 10, well, I know it would be 1. So this part is 1 times 10 to the 1 to the 10 is 1 times 0.01 to the power of 0 is 1. So we have 1 for the first part plus the 10C9. 10 shift NCR 9 equal, this is 10, is 10 times 1 to the power of 9 is 1 times 0.01 to the power of 1 is 0.01 plus, then we have 10C8. 10, I have to press shift with this calculator, and then NCR 8 equal, I have 45. So I have 45 times 1 to the 8 is 1 times 0.01 to the 2, 0.01 squared, that would be, and that is 0.0001, 3 zeros on 1, 0.0001, alright, plus, we go one more, 10C7, we have 10 shift NCR on my calculator 7 equal 120, so that's 120 times 1 to the 7, which is 1 times 0.01 to the 3, so 0.01 to the power of 3 equals, so that turns out to be, well, it's 0. I have 1, 2, 3, 4, 5 ones, 1, so it's 0.1, 2, 3, 4, 5 ones, and then 1. Alright, plus, alright, just for the practice, let's go one more, 10C6, because we might not need to go so many steps in it, you know. Well, let's just look at the 10C6. 10 shift NCR 6 equal 210. 210 times 1 to the 6 is 1 times 0.01 to the 4. Let's leave it as 0.01 to the 4. We don't have too many zeros to write. Plus, and it goes on. So let's work this out. 1 by 1 by 1 is 1. Plus 10 by 1 by 0.01 would be 0.1 plus, maybe give some space and pull this further down. Alright, plus this part, 45 by 1 is 45, multiplied by 0.0001, so 45 times 0.3 zeros and 1 equal, so what we have here is 0.0045 plus, so we didn't really need to go beyond this part, you know, but we have the 10C8, but anyway, we passed it already, so let's continue. We're going to have 120, so it's 120 multiplied by a point. You have 5 zeros, 2, 3, 4, 5 zeros, and 1 equal. Now, this turns out to be 0 point, and then you have 3 zeros, then 1, 2, Alright. Alright, we definitely don't need the next one because we're well past 3 decimal places. Was it 3 they said? Right, 3 decimal places. So we add these up. So we have 1 plus 0.1 plus 0.0045 plus 0.00012 equal. This would amount to 1.10462, but in writing it to 3 decimal places, this will be 1.105 to 3 dp's. Alright, so that's what we have. So that was 1.01 to the power of 10 to 3 decimal places. So 1.01 raised to the power of 10 equal. Alright, now let's use our calculator here now and see if we can get this thing. Our calculator. So we have 1.01 to the 10. So working it out on the calculator is that to do 1.01 raised to the power of 10 equal. Alright, so you see you have 1.04622127. 2 more decimal places. This would be how many decimal places? To 9 decimal places, that would be it. So we have it to 3 decimal places here. Alright, so that's that.